Welcome learners, I am Divyanath. Today we are going to discuss about Module 4, Lesson 8, Measures of Central Tendency, Part 1. In this module, we are going to discuss about concept of measures of central tendency or averages. Then we are going to discuss how to calculate arithmetic mean in case of individual, discrete and continuous series. After this, we are going to learn the properties of arithmetic mean. So, students, let's start with the class. What do we mean by central tendency? The measures of central tendency is defined as the statistical measure that identifies a single value as the representative of an entire distribution. So, here we are getting a single value which is going to represent the entire distribution. So, it aims to provide an accurate description of the entire data. So, once we know about the meaning of central tendency, we can discuss different kinds of measures of central tendency. Basically, there are two kinds of measures of central tendency. One is mathematical average, other is positional average. In mathematical average, we compute and it is known as arithmetic mean. So, the first method through mathematical average is arithmetic mean. On the other hand, when we discuss about the positional averages, we are going to calculate in this median, quartiles and mode. So, students, today our class will focus on arithmetic mean. How do we compute arithmetic mean in case of individual series, in case of discrete series, in case of continuous series. So, let us start and discuss the arithmetic mean first. What is an arithmetic mean? When we talk about arithmetic mean, it is the most commonly used measure of central tendency and it is computed by adding all the values in the data set divided by the number of observations in it. This is how we calculate arithmetic mean. So, once we know what is arithmetic mean, now we can calculate it in different series. Let us start with individual series. Here we are discussing that there are two methods to calculate arithmetic mean in case of individual series. One is direct method, other is assume mean method. Let us discuss direct method first. In case of individual series, when we want to compute arithmetic mean by direct method, what do? Here we have information, that is there are n number of observations as x1, x2, x3 till xn. Then arithmetic mean, which is usually denoted by x bar, can be calculated as summing up of all the item values, that means x1 plus x2 plus x3 till xn. We are going to sum up all of them and then divided by n. When we sum up all the item values, it is known as sigma x or summation of x divided by n. N denotes total number of observation. So, here is the first formula how we can calculate arithmetic mean in case of individual series by direct method. Now, let us do one of the question on it. Suppose there is question, a student marks in second term exam were 94, 87, 98, 82 and 89. Now, these are all the item values. So, they are telling us find out average marks of the students. Now, what we are going to do? We are going to add up all the marks. So, we get summation of x is 450. So, we have added 94 plus 87 plus 98 plus 82 plus 89 and what we have got 450. Then we are going to write the formula. Always write the formula before putting the values. Why? Because formulas always carry marks and they guide you. So, you should always write the formula first. So, we have written formula mean is equals to sum of x divided by number of observation. Sum of x is 450, total number of observation was 5, 450 divided by 5 is 90 marks. Students never forget to write units. So, it is 90 marks. So, we have learned how to calculate mean in case of individual series by direct method. Now, we are going to discuss about in case of individual series. As we have seen, total number of observation were 5, we have summed it up, and the next we have calculated mean in case of individual series by direct method. Now, we can discuss assume mean method, also known as shortcut method. Now, the question arises, when should I calculate shortcut method? We should calculate mean by shortcut method only when the data, that is the size of the items, is very large, or otherwise even the examiner can tell you to compute it by shortcut method. In both the cases, you have to calculate mean by shortcut method or by assume mean method. The step 1. Take any of the middle value as assumed average and put a in front of it. Then take deviation of values of each item. So, we are going to take deviation. How we take deviation? D stands for deviation is equals to item value minus assumed average. We will get D. Then what we are going to do? Then the deviations are being added up to get summation of D. Now, once we have got summation of D, then we are going to divide it by the total number of observation, that is n. Whatever we get, we are going to add it to the assume average, and hence we get the formula. Formula is mean is equals to assumed average plus summation of deviations taken from item values divided by number of observations. So, we have learned how to actually compute mean in case of individual series by shortcut method. Now, let us take an example to understand it. Here, the following is the pocket allowances of 5 students. Find arithmetic mean using shortcut method, or you can also say using assume mean method. Pocket allowances is being given to us 15, 20, 40, 65, 30. So, students, let us see how we can calculate arithmetic mean in case of individual series by shortcut method. In this, as you can see, the pocket allowances is being given, number of students is being given. There are 5 total number of the students. Over here, we have just marked 40 as assumed average because it is the middlemost value. Now, the next step is we have to calculate deviations from each item value. So, what we are going to do? D, that is deviation, is calculated as x minus a. Over here, a is 40. So, what we are going to do? 15 minus 40 is equals to minus 25. 20 minus 40 is equals to minus 20. 40 minus 40 is equals to 0. 65 minus 40 is equals to 25. 30 minus 40 is equals to minus 10. Once we have calculated deviations from each item values, then we are going to sum up the deviations. That means summation of D will be done, that is minus 30. Then students write the formula. For the formula is A plus sum of D divided by N. Now, here the value of A is 40, sum of D divided by N is minus 30 divided by 5, that comes to minus 6. So, we are going to add it. So, it becomes 34. Therefore, arithmetic mean comes to rupees 34 pocket allowance. So, we have learned how to calculate arithmetic mean in case of individual series, first by direct method, then we have discussed it by shortcut method. Now, students, we are going to discuss arithmetic mean in case of discrete series. If we want to calculate arithmetic mean in case of discrete series, we can calculate in 3 ways. We can calculate it by direct method, We can calculate by assume mean method. We can also calculate it by step deviation method. Let's discuss the direct method first. In case of direct method, the following steps should be taken. We now know in case of discrete series we have x and we have f. So, what are the steps? Very first, the values of all items of a series are multiplied with their respective frequencies. That means we have to multiply frequencies with their x item values. So, we will get a column of fx. Once we have multiplied fx, then we are going to add up them. So, what we are going to get in the next step? Sum of fx. Then in this case, the total number of observation is sum of frequencies. So, n means sum of frequencies. Then the formula comes in this case, mean is equals to sum of fx divided by total number of observation. Students, note the point that here n stands for sum of frequencies. So, once we know the steps how to calculate arithmetic mean in case of discrete series by direct method, we can now take an example to see how we can calculate it. So, in this question, the following data gives the weekly wages in rupees of 20 workers in a factory. Wages means item value in rupees 100, 140, 170, 200, 250. Workers 5, 2, 6, 4, 3. Sum of frequency is 20. That means total number of observation is 20. Now, we have made one more column fx as we know. Now, we are multiplying 5 into 100, that comes 500, 2 into 140 comes 280, 6 into 170 comes 1020, 4 into 200 comes 800, 3 into 250 comes 750. Now, the next step is that we have to add up all the multiplication of fx. Now, it becomes summation of fx is equals to 3350. Once we have calculated all this, we need to write the formula first. So, we have written the formula, mean is equals to sum of fx upon n, and we all know that n stands for sum of frequency. So, we have just put the value 3350 divided by 20 comes to rupees 167.50. Now, we can discuss about assume mean method. Now, we know in case of discrete series we have got x, we have got f. Earlier in case of individual series we have taken assumed average from x. Likewise, here also we are going to take assumed average from x. The first step, take any of the middle value as assumed average and plot it as a. The next step, x minus a, that means we need to calculate deviations of values of each item. The next step is we are going to calculate d, that is x minus a. Once I know the deviation, then what I am going to do is that I am going to multiply with the respective frequencies. So, deviations are multiplied by the respective frequencies to get FD column. Now, we got FD, we are going to add up all these FD to get summation of FD. Over here we know n stands for summation of frequency. Now, hence we can draw the formula, mean is equals to a plus summation of FD divided by n. Now, what is the difference in case of individual series and in case of discrete series over here by the shortcut method? In case of individual series we did not have f, in case of discrete series we have f. So, the formula is mean is equals to a plus summation of FD divided by number of observations and n is equals to sum of frequency. Once we know all the steps, now we can take an example to understand it better. This is the example which tells to calculate arithmetic mean by using shortcut method. We know shortcut method is also known as assume mean method. The question says, from the following data of the marks obtained by 60 students of a class, find arithmetic mean using shortcut method. So, question is given to us, marks is x, student is f. Let's see how we have calculated mean. Now, the first step, I need to plot A, assumed average. So, out of this 20, 30, 40, 50, 60, 70, the average value can be taken as 40 or 50. Over here we are taking as 40. So, A is 40. Next step, we have to make a column for deviation D, which is equals to x minus A. So, that means 20 minus 40 comes to minus 20, 30 minus 40 comes to minus 10, 40 minus 40 comes to 0, 50 minus 40 comes to 10, 60 minus 40 comes to 20, 70 minus 40 comes to 30. So, we have made the column of D. Now, the next step, one more step, we have to multiply frequencies with this deviation. That means 8 into minus 20 comes to minus 160, 12 into minus 10 comes to minus 120, 20 into 0 comes to 0, 10 into 10 comes to 100, 6 into 20 comes to 120, 4 into 30 comes to 120. So, I have made one column for FD. Now, we are going to add up this. When we add up this, it comes to sum of FD is equals to 60. Now, just write the formula first. Mean is equals to A plus summation of FD divided by number of observation, which is equals to 40 plus 60 divided by 60, that comes to 41 marks. Now, we can discuss how to calculate arithmetic mean in case of discrete series by step deviation method. First, discuss the steps. Now, when we talk about step deviation method, it is a variant of shortcut method. That means half of the steps will be the same, and we will approach a little more later on. Now, it is adopted when we should calculate step deviation method, when we can divide the deviation by some common factor, that is C. That means the deviation is such that it is coming into tens like 10, 20, 40, 30, 20. So, we can divide the whole deviations by 10. So, we have a common division or common factor to be divided. Now, the deviations are divided by C common factor to form D dash. Here, once we have attained D, we are making a D dash column. D dash is D divided by C. Once we have got the D dash, then we are going to multiply the frequencies with it. So, we will get a column of FD dash. Then we are going to do the total of FD dash. It will become summation of FD dash, and we will divide it by sum of frequency, which is multiplied by C. Now, all this will be added to the assumed average. So, the formula comes A plus summation of FD dash divided by total number of observation into C common factor. Once we know all these steps, now let us take an example to understand it better. Now, it is the same question. From the following data of the marks obtained by 60 students of a class, find arithmetic mean using step deviation method. Now, let us see how we have done it. Marks, students. Step 1 remains the same. For shortcut, identify assumed average. Again, we are taking 40 as assumed average. So, A is equals to 40. First step, we have calculated D. D is equals to x minus A, minus 20, minus 10, 0, 10, 20, 30. Now, observing D, we can easily say that whole of the values can be divided by common factor as 10. So, the next step is we have to divide this deviation by the common factor to get D dash. So, D dash is equals to D divided by C, where C is 10. Minus 20 divided by 10 comes to minus 2. Minus 10 divided by 10 comes to minus 1. 10 divided by 10 comes to 1. 20 divided by 10 comes to 2. 30 divided by 10 comes to 3. So, we have attained one more column as D dash. Now, once we have got D dash, we are going to multiply frequencies with D dash. That means 8 into minus 2, minus 16. 12 into minus 1 comes to minus 12. 20 into 0 comes to 0. 10 into 1 comes to 10. 6 into 2 comes to 12, 4 into 3 comes to 12. Now, we have made a column for FD dash. After this, we are going to sum up. That means summation of FD dash comes to 6. So, we have got the frequency, sum of frequency is 60. Now, write the formula. Mean is equals to A plus summation of FD divided by number of observation into common factor. Put all the values, we get 40 plus 6 divided by 60 into 10, again we get 41 marks. So, students, we have learned how to calculate mean in case of discrete series by step deviation method. Over here we have learned step deviation method can be done only when deviations have some common factor which can be divided. Now, once we have done discrete series by all the three methods, we can discuss now about continuous series. How mean can be calculated in case of continuous series. Mean can be calculated by again the three methods: direct method, assume mean method and step deviation method. Let us discuss how we are going to compute mean in case of continuous series by direct method. Let us see what are the steps. We know in case of frequency distribution what happens, we have got lower limit, we have got upper limit. When we have got lower limit and upper limit, we cannot use as it is to multiply or to get some value. We need to have mid values. So, to first step is we need to calculate mid values. How do we calculate mid values? Lower limit plus upper limit divided by 2. Now, once we have got the mid value, we are going to multiply with it frequency. So, we are going to get next column as Fm. Once we have got the column of Fm, then we are going to sum it up and then we are going to divide it by sum of frequency. So, hence mean is equals to sum of Fm divided by sum of frequency. So, let us see how we can calculate mean with the help of an example. Over here, calculate mean marks for the students from the following information by direct method. Marks 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Now, the very first step, I need to have mid values. So, let us see how we have done it. So, the mid value is 0 plus 10 divided by 2 comes to 5, 10 plus 20 divided by 2 comes to 15, 20 plus 30 divided by 2 comes to 25, 30 plus 40 divided by 2 comes to 35, 40 plus 50 divided by 2 comes to 45. Now, we are going to have one more column where we are going to multiply frequencies with the mid values. That means 20 into 5, 100, 24 into 15, 360, 40 into 25, 1000, 36 into 35, 1260, 20 into 45, 900. Now, the next step, we are going to sum up Fm. So, when we do summation of Fm, we get 3620, 3620. The sum of the frequency is 140. So, first we will write the formula mean is equals to sum of Fm divided by sum of F, that is sum of observations, that is 3620 divided by 140, which gives us 25.86 marks. So, let us recall the steps. The first step was we have first calculated the mid value, then we have multiplied frequencies with the mid value, then we have got the total of or sum of Fm, and then we have calculated the total of number of observation, that is sum of frequency. We have put the formula which is mean is equals to sum of Fm divided by sum of frequency, and hence we have got 25.86 marks. So, students, we have learned how to calculate mean in case of frequency distribution or continuous series by direct method. Now, let us discuss how we can calculate mean in case of continuous series by assume mean method. What are the steps by which we should calculate it? Step 1 remains the same. We have to calculate mid values. Step 2. From the mid values, we have to again identify assumed average and mark it as A. Then the next step is I have to find out the deviations. Now deviations would be x minus A. Once I have got the deviations, then what I am going to do? I am going to find out one column of FD. Once we have got the column of FD, we are going to sum up, we will get summation of FD. Now this will be divided by the sum of frequency, that is total number of observation, and hence we get the formula when we add this value to the assumed average as mean is equals to A plus sum of FD divided by N, that is total number of observation. Once we know all the steps, we can calculate mean now with the help of an example by assume mean method. Now we are taking the same example. Marks have been given, students have been given. They have been told to calculate it by shortcut method. Let us see how we have done. Step 1, mid value. We have done the mid value 5, 15, 25, 35 and 45. Step 2, deviation from the mid values, where we have taken A as 25. Why? Because it is a middlemost value. So over here we have taken A as 25. Therefore, how we are going to calculate D, that is deviation? 5 minus 25 comes to minus 20, 15 minus 25 comes to minus 10, 25 minus 25 comes to 0, 35 minus 25 comes to 10, 45 minus 25 comes to 20. Once we have got D, we are going to multiply with the respective frequencies, that is 20, 24, 40, 36 and 20. Hence we got minus 400, minus 240, 0, 360, 400. So we got the column of FD. Now the next step is we are going to sum up. Summation of FD will be done. The value comes 120. Sum of observations, that means total number of observation, that is summation of frequency, is 140. Now students, write the formula first. Mean is equals to A plus summation of FD divided by summation of frequency. Now put the value 25 plus 120 divided by 140, that is 25 plus 0.86 gives you 25.86 marks. So student, we have learned over here how to calculate mean in case of continuous series by shortcut method. Now we can discuss how we can calculate mean in case of continuous series by step deviation method. Now let us discuss the various steps in it. We now know step deviation is only possible when the deviation have a common factor which can be divided. So let us see the steps. Again the first step is mid value. We have to find out the mid value. Then I have to identify assume average and I have to find out deviation, that would be m minus a over here. Next would be we have to find out a common factor by which we can divide the whole series, that is d. So we can identify d dash over here. How we are getting d dash over here? D divided by c common factor. Then the next step is we are going to multiply with the respective frequencies, that means we are going to identify the column FD dash. Then now the next step is once we know what is FD dash and F, we are going to sum up them. So we will get summation of FD dash, summation of F, and then we are going to multiply it by C. Now all this value will be added to assumed average to find the formula. So let us see what the formula has become. A plus summation of FD dash divided by total number of observations into C, that is the common factor. So let us see how we can calculate it with the help of an example. What we have learned, we are able to calculate it or not. So this is the example. We have taken again the same example. Now let us see how we have done it. Very first step, mid value. Second step is that I have identified A as 25 and I have calculated D, that is deviation. Then after deviation, what I observed, that the whole the values can be divided by some common factor, that is 10. Then I have calculated d dash, d divided by c. Hence, when we know d dash is being calculated, we are going to multiply by its frequency. That means, what is the d dash? Minus 2. Frequency 20. 20 into minus 2 gives minus 40. 24 minus 1 gives minus 24. 40 into 0 gives 0. 36 into 1 gives 36. 20 into 2 gives 40. Once we have calculated fd dash, the sum up is 12. Frequency, sum of frequency is 140. Now student, write the formula. A plus summation of fd dash divided by summation of frequency into c. Put the values 25 plus 12 by 140 into 10. It comes to 25 plus 0.86, that is 25.86 marks. So students, we have learned how to calculate mean in case of continuous series by step deviation method. Up till now, we have calculated mean in case of all the series by all the methods, basically direct method, assume mean method and step deviation method. Now let's discuss about the properties of arithmetic mean. What we have learned? We have learned the sum of the deviations of all the values of x from their arithmetic mean is 0, because it will become to 0. If you have calculated mean and you are going to subtract it from each value, it always becomes to 0. Now the second, the product of arithmetic mean and the number of items gives the total number of all items. Mean is equal to sum of x upon n. If we multiply mean into number of observation, we will get sum of x. Now the next, sum of the squares of the deviations of the items taken from arithmetic mean is minimum. Definitely, because we have learned if we are going to take x minus x bar, sum it will be 0, and if we are going to square them, then it will be minimum. Next, if a constraint is added or subtracted to all the variables, mean also increases or decreases by that constant. We have seen when we calculated by assume mean method, isn't it? If all the variables are multiplied or divided by a constant, mean also gets multiplied or divided by the constant. So students, we have learned about the properties of arithmetic mean also. So students, I assume that you have learned how to calculate mean in case of all the series by all the methods. Thank you. Welcome learners, I am Divyanath. Today we are going to discuss about module 4, lesson 8, measures of central tendency part 2. In this module, we are going to discuss about combined mean and its computation. Then we are going to discuss about concept of weighted arithmetic mean and its computation. After this, we are going to discuss about concept of median and its computation in case of individual, discrete and continuous series. Let's start with the class. So, combined mean. When we are able to compute combined mean, if a series of n observations consist of two components, then we are able to compute combined mean. Now, in this case, we are going to have two observations n1, n2, and there will be two means given to us for the two components, mean of 1, mean of 2 respectively. Then the combined mean can be calculated as n1 into mean of first plus n2 mean of 2 divided by total number of observation of the two components, that is n1 and n2. Let's see with the help of an example what we have learned. The average marks of 3 batches of students having 70, 50 and 30 students respectively. So, here we have been given number of observations n1 70, n2 50, n3 30, and their means are being given as 50, 55 and 45. Now the question tells find the average marks of all the 150 students taken together. So here we have got number of observations as 70, 50, 30. Mean is given to us as 50, 55 and 45. In this case, the combined mean formula will be written as mean 1 for first compartment, second component and the third component. N1 mean of 1 plus N2 mean of 2 plus N3 mean of 3 divided by total number of observations, that is 70 into 50 plus 50 into 55 plus 30 into 45 divided by total number of observation, that is 70 plus 50 plus 30, that comes to 7600 divided by 150, that comes to 50.67 marks. So we have learned how to compute combined mean. Now we can discuss about weighted mean. Now when we are going to compute weighted mean, we are going to compute weighted mean when importance or significance is to be given to some of the items. Then we compute weighted mean. Now weighted mean average is the mean of weighted items. Let's see what are the steps by which we can calculate weighted mean. Very first, weights are indicated by W. Then the items are multiplied by their corresponding weights W. So we will get Wx, and then we are going to add up to get sum of, that is summation Wx. After this, we are going to divide this summation of Wx by the sum of the weights. So we get the formula weighted mean is equals to sum of Wx divided by sum of W. Now let's students take an example to compute weighted mean. In this particular question, as you can see, it is being given calculate weighted mean of the following data. Marks and their weights have been given. So let's see how we are going to solve it. Now here we are going to make one more column of Wx. We will multiply these weights with the respective marks. Now marks are x variables. So Wx will be the next column. We are going to start with W very first, 2 into 81, that gives 162. Next 3 into 76 gives us 228. Likewise 6 into 74 gives us 444. Then 7 into 58 gives us 406. 3 into 70 gives us 210, and then 7 into 73 gives us 511. Now students, we are going to sum up Wx column and we get 1961. Likewise, we are going to sum up W column, that means weight sum, that is 28. Now students, always write the formula, because if you are not writing the formula, you are not going to get marks for the formula. The formula is weighted mean is equals to sum of Wx divided by sum of W. Now put the value, we get 1961 divided by 28, that is 70.04 marks. So students, we have learned how to compute weighted mean. After this, we can discuss about median. Now what is median? Median is the positional value that divides the series into two equal parts. Now how does it divide? It divides in such a way that half of the items lie above this value and the remaining half lie below this value. Now according to one of the author, the definition is the median is that value of the variable which divides the group into two equal parts. One part comprising all values greater than the median value and the other part comprising all the values smaller than the median value. So students, we have learned the definition as given by Corner. Now let's discuss how we are going to compute median. Now when we talk about the methods of computing median, median can be calculated for individual series, It can be calculated for discrete series and it can be calculated for continuous series. Let's see the steps how we are going to compute median in case of individual series. Now, the very first step when you are going to compute median is that you need to arrange the data. Either you can arrange the data in ascending order or descending order. Now, once you have done the arrangement of the data, add up the number of items indicated by n. So, we must know the total number of items. So, we are going to count and it is denoted by n. Then find out the median items as n plus 1 by 2th item. Once we have done this, then median is equals to size of n plus 1 by 2th item. If n of the series happens to be odd number, then what we are going to do? That is not divisible by 2. It is easier to find out the median with the help of the following formula. That is n plus 1 by 2. We will get the item value and we can easily find the median value. But student, what happens when the number of observation comes to even? In such a case, first we are going to compute n plus 1 by 2th item. So, suppose it gives us 2.5th item. What we are going to do to find out the median value? We are going to do first write down the value of the second item, then add up the value of the third item and then divide it by 2. Hence, as you can see in this example also, the size of 2.5th item, what we have done? The size of the second item plus the size of the third item divided by 2. It gives us 10 plus 12 by 2, that is 22 by 2 comes to 11. Hence, we have computed median. So, students, we have learned that median can be calculated in both the cases when the number of observation is odd as well as even. Now, let us take an example to see whether we have learned or not how to compute median. Now, in this particular question, the following series shows marks in economics of 11 students of class 11th. Find the median marks. So, marks have been given. The very first step, students, we have to arrange the data in ascending or descending order. So, in this particular, we have already lined up all the data as per ascending order. So, marks have been arranged in ascending order. Very first, here the number of observation is odd. So, there is no problem as such. 11 plus 1 by 2th item. Why? Because median size is equals to n plus 1 by 2th item. 11 plus 1 by 2th item gives 6th item. Now, the next step, locate the 6th value in the marks. The 6th value goes with 21 marks. So, our median is 21 marks. So, this is how we have computed median in case of individual series. First, we have arranged the data in ascending order. Then, we have put the formula, that is median is equals to size of n plus 1 by 2th item. Then, we have written the value of n. The total number of observation is 11 over here. 11 plus 1 by 2th item. We got 6th item, the size of 6th item. We have located in the marks and it is 21 marks. Now, we can do it in descending order also. The marks have been arranged in descending order. Again, the formula remains the same. Median is equals to size of n plus 1 by 2th item. N over here is 11. 11 plus 1 by 2th item gives you 6th item. If we locate in the marks, again it is 21 marks. So, students, we have learned how to compute median in case where the observation is odd. Now, let us see when the observation is even, how we are going to compute it. Suppose in this particular question, the following series shows marks in economics of 10 students of class 11. Find the median marks. Now, here the number of observation is 10. It has changed from 11 to 10. So, we are saying the number of observation is even. Now, in this particular case, the very first step goes the same. We are going to arrange the data in ascending order. So, we have arranged the data in ascending order. Then, we have written the formula. Again the same formula. Median is equals to size of n plus 1 by 2th item. Now over here n has changed from 11 to 10. So put the value of 10, 10 plus 1 by 2th item gives 5.5th item. Now as you can see, I have highlighted the 5th and the 6th value. Over here what we are going to do? We are going to write 5th value plus 6th value divided by 2. What is the 5th value? That is 21. What is the 6th value? That is 32. And then we are going to divide it by 2. Hence our median value is 26.5 marks. So students, you have also learned how to calculate median in case of individual series where the number of observation is even. Now students, we can calculate median in case of discrete series. Let's see what steps we should take while we are computing median through discrete series. Very first, the step remains the same. You need to arrange the data. Normally we arrange the data in ascending order. But while you are arranging the data, you have to be very careful. Why? Because whenever you are moving x, the frequencies must move along with the value of x. First step, we have arranged the data. Next step, we have to make one column for cumulative frequency. Step third, write the formula for the median. It remains the same for individual series. Median is equals to size of n plus 1 by 2th item. Now you have computed the value, the item. Now you are going to look this item value in the cumulative series, and the value which corresponds to the x gives you the median value. In the step 4, what we have done, whatever the item value we have got in the third step, we have looked into cumulative frequency, and in front of cumulative frequency the variable x becomes your median. So let's see, we have learned it or not. The question is, calculate median from the following data. Marks 45, 55, 25, 35, 5 and 15. We can easily see the data is not arranged. So we need to arrange the data, the very first step. Let's see how we have done. Marks in an ascending order. So we have arranged the marks in ascending order, and the respective frequencies have moved along. So 5, 15, 25, 35, 45 and 55, the marks are there. Now the first step we have done, we have arranged the data in ascending order. The second step, cumulative frequency. We have made one more column for the cumulative frequency, that is 10, 10 plus 20, 30, 30 plus 30 comes to 60, 60 plus 50 comes to 110, 110 plus 40 comes to 150, 150 plus 30 comes to 180. So we have done the cumulative frequencies. Now students, go for a cross check over here. We have to total the sum of frequency also. So while we get the sum of frequency, it should be also 180. It ensures that whatever we have computed in CF is right. Now after this, write the formula. Median is equals to size of n plus 1 by 2th item. Over here, the number of observation would be sum of frequency, that is 180. So we are going to put the value of 180 in this formula. 180 plus 1 by 2th item. We get 90.5 item. Now this value we are going to locate in cumulative frequency. As you can see, I have highlighted the whole row. We find this 90.5th item in 110. Now just see, in case the cumulative frequency which includes 90.5th item is 110, median would be 35 corresponding to this cumulative frequency, that is median over here comes to 35 marks. So students, we have learned how to compute median in case of discrete series in this way. Now we can discuss about how we can compute median in case of continuous series. Now in this, the step 1 remains same. You need to arrange the data. Along with that, you need to compute cumulative frequencies. After that, once you have computed cumulative frequencies, you need to ascertain n by 2th item. Now what value will this give? It gives the median class. It tells about median class. So step 1, by arranging the data in ascending order, find out cumulative frequencies. Step 2, ascertain n by 2th item. Step 3, find out the cumulative frequency which includes n by 2th item and corresponding class frequency. The corresponding class of this cumulative frequency is called the median class. Students, if you do remember, in the previous question, in cumulative frequency we got the median answer, but in this case we are getting the median class. That's the difference over here. In the previous question we have done n plus 1 by 2th item, but over here in continuous series we are doing it n by 2th item. So this is the difference you must note. So again I am repeating the steps. First, arrange the data, calculate cumulative frequencies. Step 2, ascertain n by 2th item. Step 3, locate this n by 2th item in cumulative frequency, and the corresponding class will get the median class. Now the formula to compute median is median is equals to lower limit plus n by 2th item minus cumulative frequency. Now this cumulative frequency is of preceding class, the previous class, divided by the frequency of the median class into I. I shows the class interval cap. Let's see with the help of the question how we are going to compute median in case of continuous series. Now in this particular question, as you can see, weekly expenditure is being given to us 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50. Step 1, arrange the data in ascending order. It is already being done, so we don't need to. Again, along with that, we need to compute cumulative frequency also. So we have made one more column for the cumulative frequency. So it would be 14, 14 plus 23, that comes to 37, 37 plus 27, that comes to 64, 64 plus 21 comes to 85, 85 plus 15 comes to 100. And students, we need to cross check the sum of the frequency must also be 100. So once we have computed cumulative frequency, we will ascertain the value of n by 2th item. Over here, n is the total number of observation, that comes to 100. 100 divided by 2th item comes to 50th item. Now we are going to locate this 50th item in the cumulative frequency. It comes into 64. So our median class is 20 to 30 and the frequency is 27. Preceding class cumulative frequency is 37. Once again students, we have located the value of 50th item in cumulative frequency. In 64 we have got this value. Now in this we can see that weekly expenditure 20 to 30 is being given to us. So this will become our median class. The frequency would be 27. The preceding class cumulative frequency is 37. Now students, write the formula first. The formula goes median is equals to lower limit plus n by 2 minus Cf upon f into I. We will put the value. L over here is lower limit of the median class, that is 20. So we written 20 plus, then comes n by 2, it is 50. So we have written 50 minus Cf. Cf is 37 minus 37 divided by frequency of the median class, that is 27. So we have put the value 27 over here. And the class interval gap 20 to 30, between the gap is 10, we have multiplied with 10. So we get the value as shown, rupees 24.815. So this is our median value. So students, we have learned how to compute median in case of continuous series. We now know that we need to arrange the data over here also. So let's see if the question turns from continuous series to inclusive series, how we are going to compute median. We all know in frequency distribution there is inclusive series, there is unequal class interval series, there is cumulative series. So in such cases, how we are going to compute median? Students, we must convert all these different series into exclusive series. Once we have converted this into exclusive series, then we can easily compute median. In this particular case, I have taken a question of inclusive series. The marks have been given as 46 to 50, 41 to 45, 36 to 40, 31 to 35, 26 to 30, 21 to 25, 16 to 20 and 11 to 15. So, here the marks is such that it is making an inclusive series. Now, the first step we need to see that data is arranged in ascending order. And the second step is that we need to convert this inclusive series into exclusive. How we are going to do? Very first, as you can see from the last class interval, we are going to see, because we have to arrange in ascending order, that is 11 to 15. This will be our first class now, because we are arranging the data in ascending order. So, the lower limit is 11, the upper limit is 15. The next would be 16 to 20. The gap between the two limits is 1. Limits are 2. 1 divided by 2 comes 0.5. Now, this 0.5 would be subtracted from lower limit. So, what we have done? 11 minus 0.5 comes to 10.5. 15 plus 0.5 comes to 15.5. Likewise, for 16 to 20, 16 minus 0.5, that comes to 15.5, 20 plus 0.5, that comes to 20.5. We have done for the whole class intervals. Now, let us see the students. We have arranged the data in ascending order. Very first thing, we have converted this inclusive series into exclusive series. Now, this question is normal. We have done into exclusive series. We can easily find out the median value. As per the normal question, very first step we have already done, arrange the data in ascending order. We have done the data, it is arranged in ascending order. Now, the next step is we have to make a column for cumulative frequency. Now, it is 7, 7 plus 10 comes to 17, 17 plus 13 comes to 30, 30 plus 26 comes to 56, 56 plus 35 comes to 91, 91 plus 22 comes to 113, 113 plus 11 comes to 124, 124 plus 5 comes to 129. And see over here, we have cross checked also. The sum of the frequency is also 129. So, we have done absolutely right. Now, once we have arranged the data in exclusive form, in exclusive series, and we have computed cumulative frequency, we can easily compute median by putting the formula. Now, in this, very first we will calculate median class, that would be size of n by 2th item. N over here is 129 divided by 2 item, that comes to 64.5th item. As you can see, the median class for this is 30.5 to 35.5. Now, we will write the formula. Median is equals to lower limit plus n by 2 minus Cf upon f into I. Over here, the lower limit is 30.5. The previous class cumulative frequency is 56. The frequency of the class is 35 and the class interval gap is of 5. So, putting the value, we get 30.5 plus 64.5 minus 56 divided by 35 into 5. We get 30.5 plus 1.2, that comes to 31.7 marks. So, students, we have learned that median can be computed in other frequency distribution also, but for that they must be first converted into exclusive series. Once we have computed into exclusive series, we can easily compute median. So, here the note goes, in case of mid value and cumulative series, we need to convert into exclusive series. And why it is being done? Because we need lower limit in the formula which must represent continuous series. I hope students you have learned how to compute median in case of individual series, in case of discrete series, in case of continuous series as well as other type of series in the frequency distribution. So, let us see if the missing value is being given. Now, how we are going to compute median? Let us read the question because it is a good question. Here two frequencies are being missing. Find the missing frequency in the following distribution. If n is 100 and median is 30. The very first check, the data must be arranged in ascending order. Here the data is already arranged in ascending order. the next step we can see the total number of observation is given as 100, whereas the median value is 30. We all know the rules for exclusive series. We have already learned in the previous chapter. So 20 to 30, the value of 30 never includes in it upper limit in case of exclusive series, whereas it will be included in the next lower limit. So the median class, the identification of the median class comes from the median value. So median is given 30. So 30 will be included in the class of 30 to 40. Therefore, the class frequency comes 30. Let's see how we are going to compute the missing frequencies in this case. In the very first step, we have already seen the data is already arranged in ascending order. The next step, we are going to compute cumulative frequency. For the first frequency which is being missing, we have denoted as F1. For the next frequency which is being missing, it is denoted as F2. So 10 cumulative frequency, the next is 10 plus F1, then 10 plus F1 plus 25 comes to 35 plus F1, then 35 plus F1 plus 30 gives 65 plus F1, then 65 plus F1 plus F2, next 65 plus F1 plus F2 plus 10 comes to 75 plus F1 plus F2. That means the total sum of observations, total sum of students comes to 75 plus F1 plus F2. We all know that in this particular question, the total number of frequencies be given as 100. So, the first equation is being formed, that is 75 plus F1 plus F2 is equals to 100. Now, from this what we get? F1 plus F2 is equals to 25. Why? Because 100 minus 75 comes to 25. Now, we will write the formula for the median. We know median formula is M is equals to L plus N by 2 minus CF upon F into I. The median value is already given to us. We are substituting that value, that is 30. Lower limit we can see is 30 because the median class is 30 to 40. So, the lower limit is also 30, that comes to 30 plus N by 2. It is 50th item, N means 100 divided by 2 comes to 50th minus CF. In the question you can see that for this particular class, the previous cumulative frequency is 35 plus F1. Then the frequency for the particular class is 30 into 10. 10 is the class interval gap. So, over here when we find the value, we get F1 as 15. Now, what we are going to do? We are going to substitute the value of F1 in the equation of F1 plus F2 is equals to 25. Hence, we get as F2 is equals to 10. So, students, we have learned how to compute median in case of missing frequency also. Students, I think you have learned enough for the class of median, combined mean and weighted mean. I hope you have enjoyed the class. Thank you.